Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our beloved lecturer, which is Dr. Nid Shahida. We are from group project S22 are going to present to you about our final project, which is cloud computing. My name is Nurul Shazana Karim Sabiti Saleh. My matric number is AE210039, and I will explain for methodology part. The project engaged a systematic approach to turn an object detector known as a YOLO V8. The initial step involved gathering a dataset from GitHub website, which served an important role in the training of machine learning model. Subsequently, the gathered dataset underwent extensive annotation using a computer vision annotation tool called CVAC. Once the annotation process is complete, the dataset is formatted to ensure compatibility with YOLO V8 and then uploaded to Google Drive. To train the model, Google Colab is utilized along with the dataset stored on the Google Drive. Throughout the project, a Capsicum dataset is chosen to represent the various stages involved in this project. So next, here is a code system that we are using in Google Colab. The first code use the Google Drive module from the Google Colab library to mount Google Drive within the Colab environment. This enables direct access to file and directories stored in Google Drive within the Colab notebook. The second code defines the root directory path within Google Drive where the training data for the YOLO model is stored. In the third code, the Arthur-Lytic library, which is used for computer vision tasks including object detection, is installed using PIP. Using the collected data and configuration, the YOLO model is tested for 5, 10, and 20 approach by loading it from the Arthur-Lytic library. And lastly, the result including the train, model weight, and logs are securely copied from the color environment to a specific directory runs in Google Drive using the SCP's command line utility. This ensures that the results are safely stored for future analysis. And lastly, there is image in database that we are using for this project. For this project, we choose a capsicum as an object to image detection. So Google Colab is a cloud-based platform for executing Python code and was employed to facilitate the project focus on the YOLO, which stands for You Only Look Once, object detection algorithm. So the image database was set up by leveraging GitHub repositories and downloading 200 capacity images to a computer, which served as the primary dataset for training, validating, and testing the YOLO model.
Assalamualaikum warahmatullahi wabarakatuh. My name is Lukman Al-Hakim bin Muhammad. My metric number is CE210045. So I will explain on how to execute training, validating, and testing process for YOLO. Okay, the first part is we have to download the image dataset. In this assignment, we download and use 200 image to train, validate, and testing process, and we choose uh, capsicum image, which is type of a vegetable. This is capsicum. After we download the image, we have to annotate the image in computer vision annotation tool, which also called we also call as CVAT. Then after done annotate the image, we have to export the dataset into our local computer. Next is Google Drive and Google Colab part. In this assignment, we use Google Drive as a cloud storage to be linked with Google Colab. So as we can see here, this is data where we locate the image and labels. We have to create this two folder in data directory. The image will be stored will be stored the image dataset that we use in this process. Then the label directory will be stored annotation, and annotation that we create at the CVAT. After that, we move to Google Colab part. So this is the coding for Google Colab to process YOLO process. The first coding is about to mount Google Drive into Google Colab. Then we have to press the run button to mount our Google Drive into Google Colab, so that the Google Colab can read and use our data in Google Drive to process uh, for train validation and testing process. Then the second coding is about to define the route where we locate the data in the Google Drive. So this is the root directory that we have to set on our own, which is locate locate at my drive, then capsicum detector, and the last is data. Here, this is data. So if we run the code, then it will find and mount our directory into Google Colab environment. Okay. Next part is install Ultralytics. Install Ultralytics means it will install cloud library, which is like Python, NVIDIA for display, the process, and related library that will be used to excel the process. Okay, the fourth coding is about train model. This is the most important coding that will be run to train and validate our dataset. So this coding will be run based on our configuration file. This is our configuration file that we set up to train the model. Then we use epoch 5. In this assignment, we use 3 epoches, which is epoch 5, 10, and 20. Then the last one is the result for the train model will be stored at directory runs, directory that labeled as run. So here is the directory run, which is we have 3 directory, which is 5 epoch, 10 epoch, and 20 epoch. Now we look at the result. We can see completion metric of one curve, labels, P curve, PR curve, and this is will be used to utilize the evaluation performance to see whether the 5, 10, or 20 epoch it is better for the YOLO process. That's all from me. Thank you.
Hello, my name is Anisha Vitali. The next is result analysis, which is 3 epoch where we use is 5 epoch versus a low symmetric may show improvement compared to initial epoch, but the model's performance may still be relatively low. And the next is 10 epoch. The model performance in detecting capsicle image is expected to be better compared to the 5 epoch stage with fewer false positive and false negative. And the last one is we use 20 epoch. The number of correct image detection significantly increased with fewer intents for false positive and false negative, demonstrating the model enhances ability to accurately detect capsicle image. The next is best result of epoch. The best result of precision and loss is typically observed at the 20th epoch. At this stage, the YOLO V8 model has undergone intensive training, allowing it to capture intricate detail and of capsicle image effectively. Precision improved, indicating the model ability to accurately detect capsicle object with minimal false positive. Next is analysis image detection. First is 20 correct image detection, accurate localization, accurate reverse feature recognition, generalization, consistency, and minimal false positive. The YOLO model effectively localized capsicle object within the image, demonstrating precise bounding box placement around the object. Consistency across multiple image, the YOLO V8 model consistently detect capsicle object, indicate reliable performance and consistency in object recognition. The high precision of the detection capsicle object reflect the model accuracy in identifying true positive and minimizing false detection. Next, 5 main detection: low contrast or poor lighting, occlusion, variability in capsicum appearance, complex background, and insufficient training data. Variability in capsicum appearance is object may vary in color, shape, and size, leading to variability in their appearance across different images. If the model has not been trained on a diverse range of capsicum variation, it may struggle to detect them accurately. If the YOLO V8 model has not been trained on a sufficiently large and diverse dataset of capsicle image, it may lack the necessary knowledge to accurately detect capsicum object in real-world scenarios. The last one is 5 mistake detection, which is mislabeling or incorrect indentation, model overfitting, model complexity, class imbalance, and three-hole selection. The model overfitting, if the model overfitting into the training data, it may perform well on the training set but fail in generalized to new ANSYS data. This can result in mistake when detecting capsican object in real-world image. Class imbalance, if there is significant class imbalance in the training data where capsican image are in presented compared to other object, the model may not learn to detect capsican object effectively, resulting in mistake. Uh, that's it. Thank you.
In conclusion, YOLO helped the process of completing this project, which enabled us to gain a deeper understanding of the concept of cloud computing. This has been achieved by using cloud computing database such as GitHub to gather data and Google Colab's YOLO algorithm to process it. Working with the YOLO technique for object detection allows us to apply machine learning algorithm which improve our comprehension and skill in machine learning. We gain expertise in YOLO image recognition and object detection through this project. So that's all from us. Thank you.